Derivatives and rates of change, Part 4. The tangent line to the curve y is equal to f of x at the point P, a f of a, is the line through P with the slope, and we prefer to use m is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. We want to find the equation of the tangent line. So that'll be some sort of y minus y1 is equal to m times x minus x1 at the given point. We'll start by finding that point. So we have f of x is equal to 1 over the square root of x plus 1. And we'll substitute 3 into that function so that we can find f of 3. So we have 1 over the square root of 3 plus 1. So that's 1 over the square root of 4, which is 2. So that means the point we're interested in is the point 3, 1/2. So we have y minus 1/2 is equal to, we still don't know our slope yet, but m times x minus 3. So now that we have our point, we need to find our slope. The slope of the tangent line at a point is equal to f prime at that point. So we want to find f prime of 3. And we'll start by finding just f prime of x. So m is equal to f prime of x, which is equal to the limit as h approaches 0 of, and because I can already tell this will be kind of a tall function, I'm going to write my division by h here instead of having a very tall fraction. So I have f of x plus h, so that'll be 1 over the square root of x plus h plus 1 minus f of x, so that'll be 1 over the square root of x plus 1. And this right here is that division by h. And now we need to figure out some way to simplify this. I'd say we probably want to start by first combining these two expressions. So we need a common denominator. So this is equal to the limit as h approaches 0 of 1 over h times 1 over the square root of x plus h plus 1, which will need to be multiplied by the square root of x plus 1 over the square root of x plus 1, so that we have that common denominator. And then we have minus 1 over the square root of x plus 1, which will be multiplied by the square root of x plus h plus 1 all over the square root of x plus h plus 1. And now we have our common denominator. So this is equal to the limit as h approaches 0 of 1 over h times the square root of x plus 1 minus the square root of x plus h plus 1 all over the square root of x plus h plus 1 times the square root of x plus 1. And then we'll need to do a little more work, because right now we're still going to end up with 0 over 0. When I look at this mess here, I see that in the numerator I have two terms, and at least one of them has a square root, which indicates to me that I probably want to try multiplying by the conjugate. So I still have my square root of x plus 1, but then instead of a minus sign, I separate these two terms with a plus sign. And I still have my square root of x plus h plus 1. And if I multiply the numerator of something by something, I want to multiply the denominator by the same thing. That way I'm just multiplying by a fancy 1. So I have the square root of x plus 1 plus the square root of x plus h plus 1. By multiplying by the conjugate, I've created a difference of squares, so I can use my shortcut rather than having to distribute this all out. So I have the limit as h approaches 0 of 1 over h times the square root of x plus 1 squared is just x plus 1 minus the square root of x plus h plus 1 squared is just x plus h plus 1. And this will be all over and it's very not centered now, but the square root of x plus h plus 1 times the square root of x plus 1 times this whole denominator here. So the square root of x plus 1 plus the square root of x plus h plus 1. So now I have x minus x, and I have 1 minus 1, and I'm left with the limit as h approaches 0 of 1 over h times negative h all over the square root of x plus h plus 1 times the square root of x plus 1 times the square root of x plus 1 plus the square root of x plus h plus 1. And I can see that I have an h in the denominator and a factor of h in the numerator, so these will divide out. And I'll be left with just a negative 1 in the numerator. But there's still a little bit more work to do. Now we can probably try direct substitution. So we have the limit as h approaches 0, which means we're substituting 0 in for each of these h's. When we do that, we end up with the square root of x plus 1 times the square root of x plus 1, which is just x plus 1. And we have the square root of x plus 1 plus the square root of x plus 1, which will be 2 square root of x plus 1. So this is equal to negative 1 over x plus 1 times 2 root x plus 1. So that'll be 2 times x plus 1 times the square root of x plus 1. Now that we have the derivative, we can find the slope of the tangent line. So the slope of the tangent line at x is equal to 3 will be equal to f prime of 3. So we need to find f prime of 3, which will be equal to negative 1 over 2 times 3 plus 1 times the square root of 3 plus 1. So that's equal to negative 1 over 2 times 3 plus 1, so 2 times 4, which is 8, times the square root of 4, so that'll be negative 1 over 16. And that is the m that we're interested in. So overall, the equation of the tangent line to f of x is equal to 1 over the square root of x plus 1 at x is equal to 3 will be y minus 1/2 is equal to m, which is that negative 1/16 times x minus